do we remember what, like, if I say y-intercept to you for a graph, what would I be looking for? Or where would you find the y-intercept on a graph? What would it be? Yeah. It is, if we have in standard form, it's the constant term in standard form if we want to find it. But just like in general, if you were looking at a graph, where would you look to find the y-intercept? Yeah. Yeah, okay, it's just where the graph crosses the y-axis. Y-intercept is where your graph crosses, just in general, the y-axis. It has to be of the form, the point would have the x-coordinate would have to be 0, and then the y-coordinate, I'm just going to put a little pound sign to represent. It could be any number, but the x-coordinate does have to be 0 if you're crossing the y-axis. Okay, now, she was just saying, which is true, if you guys actually have the standard form of a quadratic equation, which I have right next to this, you can actually just see the y-intercept right where you have your constant term. So I can just look at that equation right now and tell you that graph would cross the y-axis at 13. If you're like, what in the world, where'd you come up with that? Anytime you want to find a y-intercept for any graph, you plug in 0 for x. So if I did that for that little example, everywhere I see an x, I would just replace it with a 0 real quick. The reason why you can see it pretty quickly in standard form is because what happens when I plug in 0, I'm multiplying by 0 in these first two terms, both of them. It wipes both of them out because you multiplied by 0, so it'd be 0 minus 0 plus 13. It's always the constant term if you're in standard form. Now, that is not the case if you are in vertex form, which is right in the example underneath this, which is why I wanted to go through that. Now, in standard form, you cannot just look at the equation and tell me the vertex. You got to do that little negative b over 2a. We're not going to review that today. We'll do that a little bit more tomorrow. But if you have what I have in this example, vertex form, you can see the vertex in the equation, but you cannot just look at that and see the y-intercept from the equation. So just going to review this real quick. If I gave you the equation y equals, I've got x plus 5 squared plus 3. Could you tell me the vertex, just looking at the equation? Like, what's the vertex? Yes. Do your opposite, copy whatever's inside with the x, that's the opposite of what it looks like. So it's what sets that equal to 0. That's what it switches from one side of the parabola to the other. So that's why that's going to be negative 5. And then outside, you just copy it down. Now, I saw a bunch of people writing down a similar question on the quiz that was like, what's the y-intercept? And they were writing 3. Or like for this question, they were writing 6. Don't do that, because what you want to do is what I just did above. It's just going to look a little different because this is a different format. If you want a y-intercept, all you're going to do is set x equal to 0 for any equation. If you're in vertex form, what you're going to have, I'm just going to, everywhere I see an x, I'm just going to replace it with 0. And then don't do anything weird here. I saw someone like foil that. What's 0 plus 5? 5, right? So don't like foil that or try to, I don't know, I had some people doing some weird stuff. That just simplify those parentheses if you can. If you got two numbers in there, just add them or subtract them, whatever it's asking you to do, and then try to square it. Don't try to foil with that. I just saw some weird stuff on the quiz yesterday. So once I do that, 5 squared give you 25 plus 3, and then y would end up being 28. So when I plugged in 0, I got out 28. So that would correspond to the point 0, 28 on a graph. That wouldn't be something I would probably ask you to graph by hand, because I would have to make it a huge graph to accommodate a 28. But we could definitely check that if we were looking at Desmos or something like that. But 0, 28 would be my y-intercept for that one. Okay, let's just practice one more. This one has an a value that's not 1. What is my vertex for that second example there? Can you tell me what the vertex would be? What do you think? 3, 6. Opposite copy. All right, now, don't write down 6 as your y-intercept, because it's not. You're just going to plug in 0. Everywhere you see an x, just put in a 0. All right, so order of operations. Let me do my parentheses first. What do I get if I take 0 minus 3? Negative 3, right? Okay, it's okay. You can talk. All right, so negative 3, that's getting squared. All right, now, then once you think about this, in your order of operations, what should I do next? I have -2 times -3 squared plus 6. What should I do next? Square the -3. Don't involve the -2 at that point. What do I get if I square -3? +9. Just be careful with that, all right? It should become a positive. Now, the -2 multiplied by that, that's what flips the graph to go upside down. So -2 times 9 is going to make that first term -18 and then plus 6. So ultimately, if I add those together, I get -12. So I plugged in 0. Oops, I got -12 as my answer. So 0, -12, that would be the y-intercept for that graph. So is anybody having a question? Just wanted to clarify that. Y-intercept, you cannot see it in vertex form. You got to plug in 0 and figure out what it would be if you simplify it. Okay. Now, here's what I'm going to have you guys do today. I'm going to do 2 different formats of this. I'm going to have you write an equation of a parabola given the vertex and just another point on the parabola, and then I'm going to do 2 on the back where I'm going to give you a graph and see if you could do the same thing, write the equation from a graph. So we're going to do that today in vertex form, which is your y equals a times x minus h squared plus k. So that's the format I'm going to use. So if I'm using vertex form, what letters in that form are the vertex? Do you guys remember? H and K. So super important. You can't mix these up or it'll mess your problem up. So the vertex, they tell me the vertex for the question we're going to do first is 5, 7. So that is telling me that's H and K. Now, if they give you a point, this is just some point on the parabola. I don't have a picture of this to look at it right now. I could sketch one, I guess, if I wanted to, but all you need is a vertex and a point to write this in vertex form. What you're going to do with the point is you're going to plug those coordinates in for x and y. The only thing I'm not going to know is what the a value is, and that's actually what we're going to solve for. So, very important, you can't mix these up. H and K have to go in for the vertex, and x and y have to go in for the point. So I'm just using this formula, and I'm going to sub these numbers in from this question. So I'm going to do, the y coordinate of the point is 9. So I put that in place of 9. A is the only variable in that formula you're not going to know. That's what we're going to solve for. X is the x coordinate of the point, which is 3. Now, this is x minus h. My h value is +5, so this is going to look like -5 in the actual formula. So it's kind of like the opposite of what it looks like. It's because I'm subtracting that h value. The k value just goes right out to the side of the parentheses, so I'm just going to put +7 if it's positive. If it's negative, I would put a minus. All right, now, do your order of operations. So we're going to do our parentheses first here. If I do 3 minus 5, what am I going to get? -2. Okay, it's okay to speak. You guys are so quiet. All right, now, what do I get if I square -2? 4, +4, right? So I'm going to take this first term. I'm just going to write the 4 in front of the a. So -2 squared is where I'm getting the 4. I'm just going to write the a right after that. Now, I know you could solve this problem in your sleep. So you're going to subtract 7. So 9 minus 7 will give you 2. Then you get 4a. Now, who thinks a is 2? No, 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 be careful, be careful. Okay, now, you gotta be real careful with this. All right, I always just see the 4 and the 2 and I go, oh, it's 2. It's not. You're gonna get a by itself by dividing by 4, so just be super careful with that because actually the a value is gonna be 1/2. It's so tricky, so just be careful. Like I said, sometimes I just automatically see the 2 and 4 and go, oh, it's 2. It's 1/2 there, so be careful with that. Now, all you need to write the equation, you need the h and k, and then you need the a, which was what we just solved for. So let me see if I can pull this back down just a little bit. So I'm subbing it into the actual formula for the vertex form of a quadratic. When you actually write the answer, you should have a y and an x. You don't want to substitute the point in there for that. So it would be y equals, our a value is 1/2, and then it would be x minus the x coordinate of the vertex, so it'd be -5. And then y coordinate of the vertex goes on the outside, that'd be +7. So that would be my answer. Is anybody having a question? Just unnecessarily took a bunch of space with that highlighter. Okay, now I'm going to practice this with you one more time. This one has some tricky negative values in it. But just remember, h and k has to be for the vertex, and then whatever the other point is they give you. For this question, they give me negative 119. You're going to sub that in for x and y, and we're just going to do this algebraically. A is what I don't know. That's the only thing I wouldn't be able to fill in for that formula to write the equation that's going to go through these 2 points. So for y, I'm going to put 19. A I don't know, so I'm just going to go ahead and leave that as a variable. In for x, grab the x coordinate of the point, which is negative 1. Okay, now, this is tricky. So my h is negative 4. In that formula, it would be minus a negative. Tell you what, I'm just going to write that step out real quick. Be minus a negative 4, and then plus my k value. My k value ends up being negative 8. When I have that minus a negative, I really have negative 1 plus 4 is what's going on. That's why I keep telling you guys it's the opposite of what it looks like. So negative 4 really looks like a plus 4 when you put it into the actual formula for the vertex form. Now, from there, just do your parentheses first. So if I do negative 1 and 4, we're going to get 3, and that's what I'm going to end up squaring. What do I get if I square 3? 9. So I'm just going to take that first term, I'm going to write that as 9a minus 8. And then we're just going to do 2 steps. I'm just going to add 8. So we get 27. And this is divisible by 9. Now to get a alone here, I am dividing by 9. So then the a value is going to end up being 3. Now, all you need for your vertex form, you need the a value, and then I wrote too big, you need the vertex, which we have to give you in the original problem there. So I'm going to write down y equals, in place of a, you just replace 3. It'd be x plus 4 squared minus 8. That would be the vertex form of the parabola that goes through that vertex with that included point, negative 119. Is anybody having a question? It's not terrible, it's just kind of got to work it out and kind of do it in a couple steps. All right, now, same question, but I'm not going to give you the vertex and the point. I'm going to give you a picture of the graph. All right, so this is literally the same problem. The same problem. I just don't tell you this is the vertex, this is the point. You're just going to pick the vertex and the point off of the graph. All right, so just come over to your graph. What would you tell me the vertex of that graph is that's at the top of the page? What do you think? 3, 4, perfect. All right, so that's my vertex, right? So if I'm going to use that algebra we did on the front, we want to make sure we put that specific point in for our HK. Okay, now I need a point. So what am I going to look for on the graph to get another point? Yeah, so what point you want to pick? Yeah, okay. Really, honestly, on this graph, there's only 2 nice points, if you will, that the graph actually goes through. The rest of these you'd have to kind of estimate. So you can pick either one. So you've got 2, 0, and you've got 4, 0. But one of those is a point. I'm going to pick, you just pick one of them. It doesn't matter. You get the same answer. The algebra is just going to look a little different. I'm going to pick the 2, 0. And then I'm going to sub that in for x and y. Now, just a quick question before I start. Does anybody know what the a value should be looking at the graph? Is it positive 4? Oh, negative 4, because it goes down. How did you know that? Yeah, if you guys think that first step in the pattern, whenever you do the pattern, is the a value. So if you go over 1, down 1, the a value is 1. If you go over 1, down 2, the a value is 2. If you look at this graph, this is over 1, down 4. So I know right now, and if you could defend that to me, you don't have to write all this work out. But if you can figure out the a value from the graph, you are welcome to use that. I'm just going to show you, if you can't tell from the graph, which like the question underneath here is a little trickier to do. If you can't tell from the graph, you can use the algebra we did on the other side. I'm just going to plug this in real quick. So in my vertex form, y would be 0. A, pretend we don't know it for a second. And then it'd be 2 minus 3 squared plus 4. If I just did the actual algebra. If you could figure out the pattern from the graph, if you could defend that to me, I wouldn't have you go through and do all this work, but you'd have to tell me how you know that that's the a value. So if you want to do that on the homework, that's totally fine with me. If you could defend how you know that. So if I take and do the algebra though, I'm going to have 2 minus 3 in the parentheses, so it'd be negative 1 squared. So if I square negative 1, this would actually just become a, because negative 1 times negative 1 is just 1, so it'd be, if you wanted to write the 1 in there, maybe you don't really need it, plus 4, and I'd just subtract 4. So the a value is negative 4, just like you guys thought from looking at the graph. So if you can look at the graph and tell me that, that's fine. You don't have to do all that work. If you're not sure, you can always do the algebra. The answer then, let me write the equation here. This would be y equals negative 4, x minus the x coordinate of the vertex, so it'd be x minus 3, that'd be squared, and then my k value was 4. So if you have a picture of a graph, you might be able to figure out the a value without doing the algebra, but you don't have to. You can do the algebra if you want. All right. This one's really hard. Can anybody tell what the a value is for this graph? What do you think? It's not 3/4. It's 1/3. Okay, I'll go through. It's this one's, especially if it's a fraction, it's really tricky to see. The a value here is 1/3. If you're like, where did you get that? So grab yourself a vertex. So 2, -1, and any other nice point. Really, we don't have too many options here. I've got 5, 2, and I've got -1, 2. I'm just going to pick the 5, 2, so I don't have to mess around with the negatives. The only thing you got to be careful with, if you can't tell from the graph, make sure when you plug this in to do the algebra, h and k has to go for the vertex, and x and y has to go for the point that you pick. And it could be any point. You could pick the -1, 2. We would get the same answer. The work would just look a little bit different. So I'm going to do that process that we've been doing on the front. So let's see, we would have 2 equals, pretend I don't know a. It would be 5 minus 2 squared minus 1. So I'd have 2 equals a times 3 squared minus 1. The 3 squared is going to give me 9. So I'd have 2 equals 9 minus 1. I'm going to add the 1 real quick. And again, here, don't just, I'm always tempted to do this even myself. I see the 3 and the 9 and I go, oh, it's 3. You got to get a by itself by dividing by 9, so it's actually a fraction. And hopefully you could tell that from the graph. It's a lot wider, so it should not be 3. If it was 3, it would be much more narrow. So the a value there is 1/3, just like you guys thought. So then to write the equation, let me just do it real quick. We'll do y equals, a value is 1/3, be x minus 2 squared minus 1 for your formula. So if you can tell from the graph, if you could defend to me, this is the pattern and that, this is how I know, fine. If not, just go ahead and do the algebra. Is anybody having a question? Okay, now at the very bottom, I'm just going to have you practice this again. So those questions, we wrote both of the answers in vertex form. So the question down here just says, convert the equations that we just wrote into standard form. So for part A, I had -4 times x minus 3 squared plus 4. I'm just copying what I had written. And for the one that we had in part B, I had, let's see, 1/3 times x minus 2 squared minus 1. So all you want to do to put it in standard form is go ahead and multiply it out, get rid of the parentheses. So just don't forget, please don't forget, don't distribute that squared. What you got to do if you're squaring something, you're multiplying it by itself, so just write whatever's in the parentheses, just write it twice. And you don't have to do it in this order, but this would be what I would recommend to you. Foil or box, whichever one you like better, just the x minus 3 times x minus 3. So I think of it as a double distributive property. I'm going to multiply x by both terms in the second set of parentheses, multiply -3 by both terms in the second set of parentheses. So if I do that, we're going to get x times x, x squared. X times -3 is -3x. You're going to turn around and get the same thing, -3 times x, so another -3x. And then please, please, please be real careful with this. What do I get if I take -3 times -3? +9. I had so many people multiplying two negatives and give me a negative, so just be careful with that. Now, this is important too. That 4 that was part of the vertex, that does not get multiplied by the a value, so make sure you do not distribute that -4 over here. You just want to distribute to what you FOILed out or use the box to multiply. I'm going to simplify it just a hair. Negative 3x and negative 3x would give me negative 6x. Then I'm going to go ahead and distribute. So I get negative 4x squared plus 24x, negative 4 times negative 6. Negative 4 times 9 is negative 36. And then I don't want to say always, but most of the time you'll be able to combine the constants together. You got two plain numbers. So on the end there, this would end up being negative 4x squared plus 24x. Negative 36 and 4 is going to give you negative 32. That would be your standard form. Now, in standard form, you can just see the y-intercept. Does anybody know what it would be for this question? 0, negative 32. It's just whatever that number is. So that's easy to see in that format. If you plugged in 0, wipes out those first two terms from standard form, leaves you with the constant. All right, you guys might want a calculator for this last one. I just want to show you with the fraction. So if I'm going to multiply this last one out, I've got a 1/3 here, which is maybe a little bit tricky. So remember, if I square x minus 2, I am multiplying that by itself. So I'm going to write it twice. And I always just kind of FOIL that first. So you'd have a 1/3. We're going to have x squared minus 2x plus 4. Be real careful, negative times a negative. So I'm going to have 1/3. You're going to have x squared minus 4x plus 4. Now, if I distribute the 1/3, this is the part, if you want to grab your calculator, you're welcome to. I'm just going to leave these as fractions for this question. So just that first term would just be 1/3 x squared. Now, if I take I'm going to write it up here. If I take 1/3 times negative 4, do I need a common denominator to multiply? No, we don't. Just straight across the top, straight across the bottom. If you multiply 1/3 by a plain number, that plain number is just going to go in the top of the fraction. So this would be 4/3 x for your linear term there. And then 1/3 times 4 are going to look really similar, but it's positive this time. So it would be 4/3. And then I have this negative 1. And I just wanted to show you real quick on the calculator. If you're working with fractions on the graphing calculator, I'm going to try and get my constant term. And I could get a common denominator. I'm just being a little lazy. So I'm going to use my calculator to do it for me. So I'm doing 4/3 minus 1. And maybe you guys know what that is as a fraction right away, but just to show this to you, if you do that, if you hit, I do this all the time, the math button, it's the fourth button down here, just hit math, hit enter twice, and that'll convert it to a fraction for you if you need that. So this would be 1/3 x squared minus 4/3 x plus 1/3 would be my standard form. And then actually that 1/3 is going to be my y-intercept. So 0, sorry, my pen's dying. 0, 1/3 would be my y-intercept. So a lot of algebra today. Is anybody having a question at the moment? The homework is super, super similar to the notes.